Welcome back. Up till now, we've done limits that uh, tended to a finite number. Like, we had a limit as x goes to 3 of x squared, and we basically had numbers. But supposing we had the function, let's say we had f of x equals 1 over x. And the graph of this function looks something like this. That's my axes. And the graph looks like this. That's not quite right, but it looks similar to this. And so as we tend towards infinity this way, this graph on this side, as we tend towards positive infinity, we actually head towards a finite number. It never touches the 0, but it heads towards 0. And we can see that makes sense because, as we head towards infinity, we have 1 over 1, 1 over 2, 1 over 3, and that keeps going on to 1 over 1000, and it just keeps getting smaller and smaller and smaller, and it heads towards 0, but it never actually is 0. So now you can probably see why we have limits, because if we didn't have limits, there would be no way to actually, plug in infinity into this equation and get anything out of it. But if we have, when we tend towards infinity, this function actually goes to 0. And there's actually a way to solve problems that look like this, and right now I just want to explain it. So in the next video, I'll actually do a couple problems where you'll see it says the limit as x tends to infinity of some function, and it's not always, it doesn't always tend to a finite number. Sometimes it might tend to infinity, which is not really a limit, but sometimes they tend towards infinity. But the functions like 1 over x, that while x tends to infinity, the function actually goes to a finite number, which is 0. So in the next couple of videos, I'll do a few problems which deal with limits that look like this. So keep watching.